To work with logarithms, we must understand their properties. Because logarithms are exponents, the properties for logs are going to be related to the property of exponents. In this case, I happen to be multiplying a times b and taking the log of that product. What I can rewrite this as is the log of a plus the log of b. And this corresponds to a property in the exponents where I have x to the third times x to the fourth. Notice my base is the same, just as it is in this log, it's base 10. And so what happens with exponents is I can take 3 and add it to 4. So that's where the log property basically is derived from. Well, let's show an example of why would I want to do this. Well, I can merge these two and write log of 50 times 2, which is log of 100. I go back to the problem. I don't know what the log of 50 is. I don't know what 10 to some power will give me 50. So if I can merge them together, now it becomes a nice number. 10 to what power is 100? 10 to what power is 100 is really what that is asking. What is the exponent on 10 such I get 100? And that answer is 2. So without this property, I would not have been able to find that without the use of a calculator. With division, the property for logs is going to be the log of a minus the log of b. Looking at that corresponding property with exponents, because again a logarithm is just an exponent, if I have this situation, if you recall, we took those exponents and subtracted them. So in this case we are subtracting these exponents. So again, to show you an application of this and how it works, log, again, I don't know what the exponent on 10 is such that I get 50, or I don't know the exponent on 10 that I get 5. But this subtraction sign says I can merge those together and get 50 divided by 5, which would reduce to log of 10. So what is the exponent on base 10 such that I get 10? That value would be 1. The third, and one of the most used properties in logarithms, is this power to a power. Remember, a log is an exponent. So I have an exponent raised to an exponent power. An exponent raised to another exponent. And if you recall, we were able to take 3 times 2. So in this case, I'm going to take the exponent of p and multiply by the exponent log a. An application. If you notice, this exponent is multiplied by the second exponent. Well, that's going to be 2 times the exponent on 10 such I get 10 is going to be 2. Now there's another way to solve this expression. To simplify it, I can just say, well, that's just the log of 100. What power on 10 gives me 100? That would be 2. So we can see that the simplification of those two expressions ends up being the same. And one of the last properties here is, what is the log 1? Well, it sometimes helps to rewrite this in exponential form. I'm asking for the exponent on 10. That's what that says. Just the word log with no base says, what is the exponent on 10 such that I get 1? 10 to what power is 1? That answer is 0.